In this video lecture we will go through emulsions, right? And we know emulsions are type of colloidal solutions. In the previous lecture at the beginning, when we started colloidal solutions, when we studied about the classification of colloidal solutions into 8 types, one of the types that we have studied was emulsions, right? And emulsions is when your dispersed phase and your dispersion medium both are liquids, right? So here emulsions are your colloidal solutions, salts, right, in which dispersed phase and your dispersion medium both are liquid, right? Emulsions is when your dispersed phase and your dispersion medium is liquid. Medium is liquid, right? For example is, if you remember, oil in water, right, or water in oil, right? Both are emulsions, both are example of emulsions. Or we say water, right? We have studied in previously also that milk is an emulsion, right? It's a colloidal solution of type emulsion, right? And why do we say milk is an emulsion? Because milk has liquid fat, right, which is dispersed in liquid water, right? So milk is your colloidal solution or your emulsion in which you have liquid fat, which is your dispersed phase. Liquid fat is dispersed in water, right? Now, one thing about these emulsions is it is prepared. How do you prepare these kind of emulsions? Oil in water, like water in oil. What you do is you take oil and then you take water. Normally you know that if you add oil in water, they form separate layers, right? So if you take oil in water, if you shake them well, right, if you vigorously shake them, the two will mix, right, and then the two forms what we call as emulsion. Emulsion of oil in water or water in oil, depending upon the quantities of either of oil or water that we will discuss in a moment, right? So it is prepared by shaking two liquids. Right? Now, there's one thing about, let's talk about the stability of emulsions. Like if we mix oil and water, right, how long will it be stable, right? If you mix the two, right, if you then keep it for some time or on standing, if you allow to stand this mixture of oil and water that you have prepared by shaking it, if you prepare to stand it for some time, you will see that the two liquids can be seen, right? Like oil can be seen floating over water, or the layer of oil and water can be seen very well, right? The layer is very well defined, right? That means it's no more an emulsion, right? The two liquids separate out on standing, right? So on standing, so that means this emulsion is no more stable, right? Because on standing it's separated out into its constituent liquids, so it's no more as emulsion, right? So on standing, the two liquids separates out and is no more an emulsion, right? It's no more an emulsion. Now similarly, if we talk about milk, right, we know that it's, if you allow milk to stand for some time, it doesn't separate out. The liquid fat and water doesn't separate immediately, right? But if you allow it to cool, if you allow milk to cool down for some time, on cooling you observe that liquid fat starts floating on milk, right? Because that liquid fat is your dispersed phase which on cooling separates out and starts floating on the surface of milk, right? But it's not that unstable like oil and water. Why? Because milk contains a protein called casein, right, which helps for liquid fat and water to mix, right? It helps, casein protein helps to intermix water and your liquid fat, right? That is why water is quite stable emulsion due to the presence of protein casein, whatever you call it, right? So now, in order to stabilize emulsion, right, we add another substance to it. We call it an emulsifier, right, or an emulsifying agent. What emulsifier or emulsifying agent do? It helps for the two. It helps the two liquids to intermix. It helps in the intermixing of two liquids that are trying to form an emulsion, right? So we have something known as emulsifier, right? Emulsifier or emulsifying agents. These help the two liquids to intermix. Example is your soap that we are familiar with, right? Let's see how it helps. We know that soap is CH3 CH2 whole 16, right? COONA, right? This is the formula for soap, right, that we are already familiar with. We have earlier done this when we studied about regarding cleansing action of soap, right? So here we know that this soap, the molecule of soap, when added to water, it will dissociate, forming CH3 CH2, right, whole 16 COO minus, right, and then sodium is your positive ion, right? So here this part, this hydrocarbon part, if you remember, we call it as hydrophobic. Hydrophobic means water hating. So this is insoluble in water, but this is soluble in oil, right? And this part COONA, which has charges, right, plus and minus, positive and negative charges, this part we call this part as hydrophilic. Hydrophilic means water loving, right? So this part is water soluble, right, and this part is your oil soluble. We know that oil is also hydrophobic, right? So hydrophobic part of this molecule will interact with hydrophobic oil, and hydrophilic part of this molecule will interact with water, because water has charges, so it can easily interact with water. That is why it is water loving, hydrophilic, right? So what happens is, if you take, suppose this is water, right, and suppose this is water and you have a drop of oil here. Let's see, what we are trying to understand here is how this emulsifying agent soap helps the water and oil to intermix, right? This is your oil, right, and this is your water, right? Suppose if you have a layer of soap around oil, right, on the surface of oil, so how it will interact with water and oil, how this molecule of soap will interact with water and oil. Since I said this hydrocarbon chain is hydrophobic, right? This will interact with oil, which is also hydrophobic, right? And this COONA, right, that has charges on it, it is hydrophilic, so it will interact with water, right? So this is how this, so in this solution, this hydrophobic chain, this hydrophobic carbon chain, or we call it as R, if you remember, RCOONA. This R is your organic part, right? This is hydrocarbon chain. So this hydrocarbon chain will interact with oil and this COONA, right? Which we call it as, if you remember, we call it as head, hydrophilic head, and this is hydrophobic tail, right? So this hydrophobic tail will interact with oil, which is hydrophobic, since oil is also an organic compound, right? So this is organic part which will interact with oil, right, like this. And this circle represents this negative sign, right? And sodium will float in water, right? It will go in water as sodium ions, and this is how it will interact, right? I'll just draw this outside. If this is the drop of oil, right, and you have a layer of soap around it, right? So this is how it will interact. This wavy line represents this hydrophobic chain, right, organic chain, and this circle represents the COO part, this hydrophilic head, right? So this is how this soap molecule will interact with oil, right, and water around it, right? And this, what we call this as, this is a spherical, these are spherical ionic micelles. So this forms a micelle, we call it as micelle, right? So this is how this soap, right, which is an emulsifying agent, helps water and oil to mix, right? And what it does is, it also reduces the tension between water and oil, right? And when it reduces the tension, it helps oil and water to intermix, right? So this is how an emulsifying agent or emulsifier help for the interaction between oil and water, and hence this type of interaction of emulsifier helps for the stability of emulsion, right? Or it helps emulsion to attain stability, right? So emulsifier agent, these help liquids to intermix, example soap, right, thereby increasing the stability of emulsion. Now if you shake oil and water with soap, right, if you add some soap to oil and water, it will not, on standing, the mixture of oil and water will not separate out, right, because of the presence of this emulsifying agent, which will help oil and water to intermix, right? I hope this is clear, right? Now let's look into the types of emulsions. There are two types of emulsions, right, that we will study here. One is your oil and water emulsion, the other is your water and oil type of emulsions, right? First is your oil and water emulsions, we also denote it like this, and other is your water in oil emulsion, denoted like this, right? Now the type of emulsions depends on which one of these two, oil or water, we are taking in excess, right? If the term oil, right, or I'm sorry, emulsion in which in which oil is dispersed phase, right? In here emulsion which is oil in water, right? Here oil is dispersed phase, right, and water is dispersion medium, right? And here emulsion which is water in oil, here water is dispersed phase, or we say water is dispersed in oil which is dispersion medium. Water is dispersed in oil, and here oil is dispersion medium, right? Now one more thing, since here we said water is dispersed in oil and oil is your dispersion medium, right? So whichever of these two is in excess, right, that will act as dispersion medium, right? So here, since oil is your dispersion medium, so oil is in excess. Here water is dispersion medium, so water is in excess, right? So oil in water emulsion, the example that we have discussed earlier of milk, this milk is oil in water emulsion, right? Here milk is what? Milk is your example is of this is milk, and vanishing cream is also example of the same, right? Milk is an example of fat dispersed in water, right? Here liquid fat, right? I've discussed earlier also that here liquid fat is dispersed in water, right? Milk, liquid fat is dispersed in water. So this is oil in water type of dispersion, right? Similarly, if we talk about water in oil emulsion, the example is cod liver oil, right? Oil in water. So oil is in excess, right? Example is your cod liver oil. Butter is also an example where water is dispersed in oil. Oil is in excess quantity in these kind of dispersions like cod liver oil, butter. These are examples of water in oil emulsions, right, where oil will be in excess, right? Now, right, so here one thing is clear from this discussion, that the type of emulsion depends on whether we have oil in excess or water in excess, right? So I hope this is clear to you, right? There's nothing much to understand here. It's quite simple thing, right? So the important here, just try to understand what are emulsifying agents or emulsifiers, right? And example of emulsifiers are also proteins, right? Gums, all these are emulsifiers. Protein is, I've mentioned you that milk contains casein, which is protein, right, which helps liquid fat and water to mix, right, to form a stable emulsion. That is why your milk is quite stable, right? Now we have one more thing, how to test what kind of emulsion you have. Test, right? Test of emulsions, right? Test first would be add water. If water mixes well, right, that means it is oil in water emulsion, right? Because water is oil in water emulsion, we have water in excess, right? So if you add water to it, it will easily mix because water is in excess, right? Add water if it mixes well, right? So let's just understand like this. Add water, right? If it mixes well, it's oil in water emulsion, right? Second is in this only add oil, right? If oil mixes well, right? If you add oil to the emulsion, if oil mixes well with the emulsion, that means it has more oil. It is water in oil emulsion, right? So it is, if add oil, if it mixes well, then it is water in oil emulsion, right? And the other test is, and you can easily see this mixing under microscope, right? So that is why we call it as microscopic test, right? This one is your microscopic test. We call this as microscopic test. Second test is your conductance test. Conductance test, how will you test? Add an electrolyte to the emulsion. If the conductivity increases, then it's oil in water emulsion, because electrolytes can easily, electrolytes we know when added to water, the conductivity of water increases, right? The conductivity increases on adding electrolytes to water, right? We have already studied this under electrolysis, right? So conductance, to using, how to test what type of emulsion we have using conductance method is, you add electrolyte. If conductance increases, right? If conductance increases, that means it's, if conductance increases, it is your oil in water emulsion, right? If it is not affected, then it's water in oil emulsion. If conductance is not affected, then it is water in oil emulsion, right? Now there is another test, which is your dye test, right? Dye test. In dye test, what we do is we take one oil soluble dye, right? So oil soluble dye would be soluble in oil, right? A small amount of an oil soluble dye is added to the solution, right? Or added to the, emulsion, right? And if it is water in oil emulsion, it becomes deeply colored, otherwise it remains colorless, right? Add oil soluble dye, right? If it is oil, if it is water in oil emulsion, right? Since this dye is soluble in oil, so it gives you a deep color, right? And if the color is not impacted, if there is no effect means it is water, oil in water emulsion, right? Because dye is insoluble in water is in excess in oil in water emulsion, right? So no effect. Whereas since dye is soluble in water, dye is soluble in oil, so in this type of emulsion where water is dispersed in oil, right? So since what oil is in excess, so this dye will interact with oil, giving you a deep color, right? So these are three tests for emulsion, to test whether the emulsion is oil in water or water in oil, right? And now we have some properties of emulsions. In properties of emulsions, since we know that emulsion is nothing but it's a type of colloidal solution, right? Since it's a type of colloidal solution, so it will show all the properties of colloidal solution that we have studied earlier, that is Brownian movement, electrophoresis, right? All these kind of properties will be shown by emulsions, right? So if you remember what all properties we have studied Tyndall effect, right? Coagulation, Brownian movement, right? Electrophoresis. All these are properties of colloidal solutions, right? So properties, you have Tyndall effect, right? Tyndall effect is if you pass light through this emulsion, it will show the colloidal solution, that is the emulsion, will get illuminated, right, when you pass light through it. So it shows Tyndall effect, and it shows electrophoresis. Electrophoresis is if you pass electric current, or if you apply electric current, right, using positive and negative electrode, the dispersed phase particle will move towards either of the electrodes, right? So Brownian movement, it will show Brownian movement as well. And as per Brownian movement, if you look under under microscope, right, you will see that the colloidal particles are moving like this in zigzag fashion, right, which was discovered by Robert Brown. So this is Brownian movement, right? So it shows the properties of colloidal solutions, right? Now you have emulsions can be separated into constituent liquids, right? There is something known as demulsification, right, which is demulsification, right? You have something known as demulsification, right? Demulsification is if you have an emulsion of oil in water or water in oil, right? If you separate the two components, water and oil, that is your demulsification, right? So demulsification is the process of separating of the constituent liquids of an emulsion. Separating constituents of an emulsion, that is separating the two liquids, since emulsion is made up of two types of liquids. And emulsion can be diluted. This is one of the properties, that emulsion can be diluted. If it is oil in water emulsion, right, so you can add water here is your dispersion medium, so you can add dispersion medium to dilute your emulsion, right? And if it is water in oil emulsion, here oil is your dispersion medium is always in excess, oil is in excess, so this is dispersion medium. So you can add oil to it in order to dilute this water in oil emulsion, right? Now we have some harmful effects of emulsions. Water and oil or water and petrol can intermix, right? So sometimes in petroleum wells, right, you have some water mixed with petroleum and it forms an emulsion. So there you don't have pure petroleum, you have water mixed with it. Similarly, in oil well, in water wells or in rivers somewhere, right, if you have petrol there, right, accidentally or from any source, if you have water, if water can go into the wells or rivers, right, it can form an emulsion of petrol in water, right? Water and petrol can form emulsion. So that water, river water or your water in wells, the water can be rendered unfit for drinking, right? So these are harmful effects of emulsions, right? For harmful effects of the formation of emulsions, right? And you have certain application of emulsions, right? Under applications, if you remember, you have milk, which is an important constituent of our diet, right? And milk, we know, is an emulsion. Similarly, if you remember, among the common uses, we have Dettol, right? Dettol and several Dettol and several oily drugs are prepared in the emulsions, right? And Lysol, Dettol that you have, right? Lysol, people normally use these things as disinfectants, right? These are disinfectants which are emulsions. Similarly, you have some oily emulsions, right? Some medicines, right, which are oily drugs, right? You have oily capsules which are emulsions, right? That are drugs, right? So these emulsions are used to make drugs as well, right? Then you have we have studied about regarding cleansing action of soap, that we have already studied. So cleansing action of soap is also come under the application of emulsions, right? Then the digestion of fats